Liberal arts.
Okay. Ladies and gentlemen.
Do you take power in politics?
We're going to take a look at this approximation of the derivative function before we move on. May I have your attention? All right. The interesting part is what we tried to do is bury this function inside a function, and the syntax for it is pretty atrocious. So here we have, at this level, a function called df, and I'm passing it two parameters, f and x. What are f and x? Well, if I move up here, this is the function df. Looking at df, you see we have this strange thing called the function, and it's f. I'm not quite sure what this is, but I know it's a data type. The function is a data type. Here's x. It is a data type double. But what is this f? I use this new word that you might not have seen in Mac 101. It's the defined type. It's a reserved word in the language C++ and in C language, where it allows you to write complex things, to replace complex things as one word. So I have this complex thing here called double star, and you know star means what now? So whatever der fun is, it is a pointer. A pointer to what? Remember how functions are written. Functions are always written, if you look up to, say, double H, the name of the function, open parenthesis, and then what? Close parenthesis. So you have the name with an open parenthesis and close parenthesis. The parameter, this parameter is called what? Double x. Is it an actual parameter or a formal parameter? Formal. Exactly. If we move down to define type, ignore the word define type. You see double, and ignore the star, but you see the word defun, which could be a name of a function, open parenthesis, close parenthesis. This is actually a prototype. It says you're going to have an argument of a double. The thing is called defun. It's pointing to a function. It is very awkward syntax. So I'm going to go through some examples with you using code blocks. Yes?
Don't you need the ampersand sign once you're calling it?
I didn't. There's the semicolon. That's all I need. We'll fix that. Everything will sort of not make sense, or it will. Here's a function, a general fun-loving function. We'll say it's an integer. It adds two numbers together, sum. Give it an integer. And give it an integer. And I better give those integers names. I'll call it P and Q, just so I'm using something different than I use on the board, P and Q. Integer total. I'm writing this out the long way. P plus Q. Return total. A fun-loving function. And if we look at the function, it has, its prototype is integer, integer, integer. Notice the basic idea here is you see this. Integer, write this in lowercase, integer, a name, a parenthesis, stuff, and a close parenthesis. What I'd like to do is have something to point to this. Now the stuff, for in our case, will be integer, comma, integer. That's our stuff. Look down here. Integer. I don't care what the name is. Remember, these names are dummy placeholders. The first parameter is called P. It's an integer. The second parameter is an integer, and we call it Q. P is a copy of some value, and that copy is put in Q. and the copy is it's a copy of an integer, of course. And here we have the second parameter, excuse me, p is the first parameter, q is the second one. A copy of p and q, whatever the values are, added together, put into the memory location known as total. The copy of the value of total is then returned as our answer. Again, looking at this prototype up here, the basics are, the name, in our case, is sum. Now, if I leave it like this, it looks like a prototype. However, if I put a parenthesis star, parenthesis around it, and I give this thing a name, I'll call it foo. This is now, foo is now a pointer. It's no longer just a fun-loving function. I've changed it just by adding this syntax, parenthesis star, close parenthesis. It is no longer a prototype. For example, here's sum. This is a prototype. I'm going to change that prototype. It's no longer a prototype. I'm going to say star sum, integer, comma, integer. Not a prototype. This is now sum points to a function that, I should put a slash up, slash, slash, so it looks nice. Otherwise my compiler will yell later. Slash that looks like integer function, if I can spell the word function, pointer, integer, integer. Anything, I should say name, excuse me. Any function that looks like integer, I don't care what the name of the function is, it returns an integer, it's got some crazy name, it accepts 2 input parameters. That's what the line now represents. It's a strange syntax. So this would match, I'll show you what it matches. For example, if I said integer divide, parenthesis, integer, comma, integer, would it match that? Does this match this?
No.
Yes, it does. I'll put an F there. I'll put a foo. I'll put fun, the word fun. That's what most people would do, to put the word fun for function. This is a variable. It is named fun. It's not an integer. It's a pointer to a function that accepts 2 integers and returns an integer. So look at this. I don't care what its name is. It's a function. It accepts 2 integers and returns an integer. A function accepts 2 integers and what? Returns an integer. It matches. Matches fun. How about this one? Integer, sub, integer, comma, integer. Does that match?
Yes.
What about this one? Double. Okay, you got it already. Add, integer,
What do you mean by match?
comma, integer. That's what you're learning by looking at it.
You mean just
There's a
like-
pattern. The only thing that can change is the name. Notice the name changed. Div, add, but it still matched fun. Now notice the subtlety in the syntax here. I'm going to change this to the word fun up here, fun. This first fun is a prototype. The second one is not a prototype. It is not a prototype. We're actually creating a variable. I'll make sure you know that because I'm going to say it creates a variable. but it's a variable with a pattern. The pattern is based on function matching. Here's another one. Let's say if this matches. Integer. Foo-foo. Integer double. Does foo-foo integer double match? Well, you got integer, integer. Foo-foo, okay, fun. Integer, integer. Does double match integer? No, so no match. No. No. This is the basic idea behind it. Matching. It'll match anything. And how could we use this if it's a variable? We'll play around. There's sum. And here I have, I'm going to get rid of this thing because I want this to compile nicely without having problems. Here is fun. Fun is a variable. I'm going to take that variable, cut it out of here for now, cut, move it down here in my Hello World program. There I have a variable. And I'm going to say fun equals something. Fun, I said fun, equals. Notice when I type out the word fun, what does it say? Function. It is a function, but it's a variable function. I'm going to say fun equals sum. Now in C++ and in C language, what will happen is if you use the name of a function, it means the address. Where does the function live? So the name alone, sum, is the function's address. Where does that function live in memory? Where is that program? That Wascally program? Where is it? I don't know where it is. I don't know, and I don't really care. But guess who knows? Fun knows. Fun knows, and fun, we want to have fun. So we're going to ask fun to do something for us. See out. I'm going to ask fun, add numbers. Fun, add some numbers. Okay, let's get the answer. Fun, would you do me a favor and add the numbers 3 and 4 and give me the answer? If I could spell end right, L. I'm going to get rid of this stuff. We don't need to see that. I'm going to delete this up here. I'm going to adjust the screen for you. We don't need to see this. It's recorded, hopefully. Here we, again, so let's review. We have a function called sum. There's a pattern here. It's integer, blah, 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 blah. We'll say function name, comma. That is the pattern. The name of the function integer and parameters, whatever those parameters are, and specifically it's integer, integer. Down here I created a variable, but not an ordinary variable. Notice I did not say integer fun. No, I did not say integer fun. I said integer parenthesis star fun close parenthesis integer comma integer semicolon. That's a variable. It's a weird looking variable because it's very complex. It's a weird looking variable because it is complex. So what I'd like to do now is run this program. If I ran it, fun will be pointing to sum. We can build it and run. Nope, I have no errors. Whoops. And notice 4 plus 3 is lucky number 7. In the movie, the poor guy whose name is 7 isn't very lucky. I forget if it was a good movie or a bad one.
Oh, it's pretty good.
It was pretty good? Yes.
If we create that function variable as a prototype on the top of it, do we have to type in the same thing in the main, or?
No. His question, if I understood you correctly, and do we have to type it in here? No, it's a regular fun-loving variable. We could have typed it in right here. And now it's a global variable. All functions underneath here can now see it. I'll prove that to you. Watch this. I'm going to cut this out. Snip. Snip. And I'll write another function. Boo. Great names, huh? Give me a moment and I will clean this up. I'm going to put it in a function, put this in boo. There's boo. 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 Boo, here's the variable. This is now a global variable.
Is it a global variable or a global function?
No, it's a global variable. It's a variable that points to a function. It's a variable. Variables don't always have to point to numbers. They can point to or reference structures, objects, but mostly what? Numbers. Everything in the computer is really a number, right? And we have our fun-loving global variable. Whoops, get back on that screen. And now get rid of some of this dead space. Now I'm going to call boo, but we'll have a problem here that we'll fix. Yes, there's a problem. When the compiler sees the word boo for the first time, it gets frightened because it doesn't know where boo is. Boo's all the way down here. Compiler doesn't know. So let's let it crash and get this over with. Boom. Its complaint is error. Boo was not declared in this scope. I don't know if you can see that, but here it says boo is not declared in this scope. Scope is computer science for what word? Range, thank you, range. Was not declared in this range. It says it's out of range. The compiler cannot see the future. Anything going down is the future. So to let the compiler sort of have a premonition that this is coming up, right up here someplace, anywhere, I'm going to write boo, and I'm going to put a semicolon at the end. This is now a prototype. It's not a function pointer. It is a prototype. It is a prototype. It says, here's what happens. When I compile this program, I'll just build it. Build. No complaints. Here's what's happening. Compiler sees this command, says, go get in the IO, the input, output stream library. Got it. If something is missing, put std in front of it. Everything inside IO, everything in here is like, for example, std : cout is in there. std : cin is in there, etc. I don't want to write std : all the time. So this is a shortcut. Avoid. That's its only job. Makes our life easy. Less typing. Next, the compiler sees this word, void. Boo. Okay. It says, do not get upset when you see the word boo. I'll tell you what's going to happen later. Now I see sum. There's what sum is. Got it. Here's a new variable, fun. It's a global variable that can point to matching functions. It can point to matching functions, and we went over what it means to match. The only thing that can change is the name. Now we get to main, integer main, great, we start building it. Think of a construction crew is out there. It gets to boo, it says, okay, I don't know what the blueprints are for boo, but I'm going to leave a spot right here of land. I'm going to leave a couple of acres right here, and that's going to be for boo. and it starts building the code. Now there's a hole in main, a big hole. It says I have to go to boo. The compiler gets to this point, and it peekaboo. It's found boo. So what'll happen is the compiler will then do this. This code will be go to boo. It's right underneath me. You know, go to boo, dot, 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 because now it knows where it is. It's right here. Here it is. The address of boo is boo. That's its address. Boo. Boo, that's where it lives. So I should get rid of the parentheses there. Go to boo. Now if I run this, we'll go to boo. Boo will then say take sum. And where is sum? Sum is up here. It knows where sum is. It knows where it lives. Take the address of sum and copy it into fun. There's where fun is. And then we'll say, this point is very important. Notice the parentheses are back. When the compiler sees parentheses, it means use it as a function now. Here, in boo, fun equals sum, it says use fun as an address pointer. Don't use it as a function, use it as a pointer. Because functions always have what at the end of the name? Parentheses. There ain't no parentheses here or here. Use it as a what? Say pointer. Pointer. That's it. That's the rule. It takes a long time to get this to turn over. Intellectually, you might grab it, but then to, like they used to say, like 5,000, was it 2,000? Over 2,000 years ago. You know, they used to think your brain was in your stomach. They thought that's what you thought, because I think it was the ancient Greeks said, your brain is down here. People would say, why? Because when you feel it in your gut, you know it. So that's what must be my brain. It must be down here, because my head doesn't feel anything. Like emotions and all that stuff of different parts will forget feelings. Like appendicitis, I forget what that meant. All right, let's run this program, and it should do the same thing as before if I don't have any bugs in it. Build and run. Now we can have even a little bit more fun before we move on. Let's create another function. Because I call this function madness. I'll call this one diff. What do you think diff stands for? Yeah. And I'm going to change this to a minus sign. So how many functions do I have now defined? Two. What are their names? Sum and diff. Where do they live? Where does this function live? What's its name? Its address. This one lives at sum. This one lives at diff. Now watch this madness. I'm going to change this word from sum to diff. And I'm going to run the same program. I should get -1 now. Take a look at that for a minute. This is, maybe I should like slow down and dwell on this for a little bit with you guys, huh? How are you guys holding on? I'm not getting a lot of hands up there. I get one or two good, one like some nervous smiles. All right, I'm going to take a 10-minute break, but it's not a break for you to necessarily go wander the halls, unless you need to. If you need to take 10 minutes and wander the halls to let your brain unwind, do it. Otherwise, let's take a few minutes to type this in, and you work on it. I'll print it out on the printer. I think that thing's working, yes? Anyone know if that printer's on? Because what happened was we ended up getting students from all the departments come in and print out textbooks on these printers, and they've been burning out two things. The duty cycle of these printers are being exceeded. That means they burn out. You can only print so many thousand pages a month, and then you wear it out. Because they're the mechanical parts, right?
Mm-hmm.
They wear out. You also use up the toner, which is expensive, which we run out of money. We run out of paper. So that's been kind of happening. All right, let's see. Print. Active editor? Yes, that's all I want printed out. Print line numbers? Sounds good. Yes, I saw a hand up. Print driver. And action. I only printed one. Well, let's see how one prints out, right?
I think you need to release it.
I think it's released. Yeah,
Let's go to the office and release it.
Ah. Wait, I hear it firing up. Whoa, hot off the presses. Here, pass these things around. Oh my goodness, this is incredible workmanship here. I don't know who wrote this program, but it's incredible. Soon it'll be your incredible work. This technique I'm showing you eventually is incredibly powerful, as simple as it seems. There's great power in simplicity. Look at these computers. They're all based on what numbers? Binary. Ones and zeros. Yeah, with ones and zeros. Let's see, pass 3 over. Did I get enough or need more? Looks like I need one more here, and how are we doing here?
Good.
Am I one short? Are we all good? All right, bingo. Good, type this in and think about it. I'll turn the lights on, put some Baroque music on, and fire up the neurons. And I shall turn off the recording of silence. Okay, so, excuse me, ladies and gentlemen, so we have a variable here, fun. Fun is a variable. I can have data types and I can have arrays of fun, which we'll look at later, is how to create an array. Create an array of functions. That means you'll have function 0, function 1, function 2, function 3. Just like we had music. Remember we had music, we stored the data in an array? Remember that? So I hope so, yes. Or a beep bop music array. We can store functions, not just tones in it. And that means, in a sense, we could write programs and store programs in an array inside a program. So we'll play around with that a little bit in our next episode. We can also create more functions. For example, where is my function? Here it is. If I want, I could have 2 variables. Here's another variable. I'll call it function number 2. Not a very creative name. But I now have 2 variables that can hold what? Hold addresses of functions. That's what function 2 can do.